All right, welcome back for video 2. So we're going to continue on with this section of notes. And again, I hope you've tried these. This is a discovery-based activity, so it's stuff that you can kind of figure out on your own if you work through these problems. It's not easy, but it's definitely within your reach. So when we look at example 2, first thing, just like the last one, we're going to go ahead and put the information we have. The parallel lines is already marked. So next thing, we've got SV is 3. All right, VR is 8, UT is 12, and it wants us to find SU here. All right, so at this point, if we leaned on what we saw last time, all right, we could try and do x over 3 equals 12 over 8. But that's really what they're asking me, is that true or false? All right, so we're going to work through it the old way and see if we do get that pattern to work with. All right, so we're going to start and we're going to write this with this small triangle, SVU. All right, and again, I'll do one tick mark on each of those, 2 on these. The parallel lines, corresponding spots gives us that. So I have 1, 2, and then S. And then on the next one, which is the SR and T, SRT, we have 1 tick mark and 2. If I carry my measurements over, I've got 3 and an X. And on this side, I'd have an 11, the full length, 3 plus 8. And on this side, an X plus 12. All right, so based on our hypothesis, we think it might be x over 3 equals 12 over 8. So 8x equals 36. Divide by 8, x equals, let's see, that reduces to an 18 over 4 and 9 halves. All right, so we're anticipating a 9 halves. So let's go through this and see, using our old methods, if we get that same 9 halves. So I've got 3 over 11 equals x over x plus 12. Cross multiply, 3x plus 36 equals 11x. So far it's looking good. Subtract 3x, and we end up at 36 equals 8x, or x equals 9 halves. Now, sure enough, that was what we expected. All right, the SV over VR and the SU over UT, all right, that is another true statement. All right, so I feel like with those two, we're going to start feeling pretty comfortable that we can look at that ratio by comparing here to here and here to here when we have the same characteristics, which is that the line through the middle is parallel to the base. All right, so let's look at the next one. It says make a conjecture based on your answers to the two true-false questions above. And it says if AB is parallel to DC, right, then, right, and what we saw is that we could take AB over AE and set that equal to BC over ED. All right, so it's almost as though those parallel lines are cutting off proportional pieces. All right. There are other ways that you can do this setup, because remember, with a ratio, we can always flip both sides over. All right, we can also exchange the pieces on a diagonal. All right, but again, I wouldn't stress too much about that as long as you know this to this equals this to this, as long as we have those parallel markers there. All right, without the parallel markers, this one falls apart. We might have one of those ones where the inside triangles may be twisted up compared to the other one. All right, so we want to be careful about it. Now, I would say our informal argument here is we can do it through example, what we showed before. All right, we can also talk them through the fact that parallel gives me similar triangles. All right, and then once I have the similar triangles, I can set up the proportions. All right, so I hope that takes you through and you feel comfortable with that new rule. That's going to come in really handy on a couple of the homework problems. All right, so I'm going to go ahead and stop this video, and I'll be back to work through the last little part of the notes with you in the next one to see if we can come up with the converse of that and show that as long as we know that ratio, we can guarantee the two lines are parallel. All right, thanks, and see you in the next video.